Hello, everyone. We are thrilled to have Amazon Web Services as the platinum sponsor for the SCA 2024 conference. And today we have the pleasure of speaking with Ian Colle, the General Manager of Advanced Computing and Simulation at AWS. And Ian has been instrumental in shaping AWS technological landscape and has made significant contributions to the development of cutting-edge solutions. Welcome, Ian. Just start by sharing a bit about your background and journey in the technology landscape, especially your role at AWS. We're really interested in hearing about your experience and the key initiatives that you've been involved in.
It's really exciting to be here, and I'm really excited to be at SCA this year, especially with it being the first time, in Australia. Really excited to be there and participate. At AWS, I've been here since 2017. I joined from Red Hat, where I had served as a director of engineering. I got primarily a storage and infrastructure background, and I joined AWS to really establish the high performance computing business unit at AWS at that time. We were really looking at how we could grow the high performance computing workloads that we supported on AWS. And we had a lot of work to do, both from a business and a technology standpoint, to ensure that we had the infrastructure that could support some of the world's most demanding workloads, which, as we all know, supercomputing workloads are. And now I'm really excited to say here we are, a little 6+ years later, where we have such things like our low latency interconnect elastic fabric adapter, which is comparable to InfiniBand for many workloads. We have dedicated high performance computing instances on AWS. That's our compute platforms that are both an AMD flavor. We've got an Intel flavor and our own ARM-based Graviton flavor. And we've seen lots of interest, especially in the ARM ecosystem around HPC workloads, especially with the success of Fugaku in Japan. And been really excited to see kind of how they've led the way on the presence of ARM in high performance computing. Because what a lot of our customers and I think the broader supercomputing industry as a whole have started to see is it's not only about the workloads we perform and price per performance, how much we spend to accomplish those workloads, but we need to start looking at a world where we're looking at the performance per watt. What is the actual impact of the resources that we're consuming to achieve these workloads? And so ARM is especially interesting there because of their ability to have such power performant chips. And that's where I think our HPC7G, which is quite similar to the Fugaku system, is interesting. So all that to say is we've really had a pleasure of these past 6+ years of developing a broad offering from AMD, Intel, and our own ARM-based Graviton chips, as well as our low latency interconnects. FSX for Lustre is our managed Lustre offering. So we've really built up an entire supercomputer on AWS of storage, compute, and networking in the cloud. And that's, it's pretty exciting to see where we started out, in 2017 when I joined to where we are today. I mean, the conversations I'm having right now with national laboratories around the world, with meteorological offices, talking about replacing some of these extreme scale on-premises supercomputers are things that were unimaginable when I joined in 2017. So it's just really exciting times in the industry.
Yeah, thank you, Ian. Sounds really exciting. So, given your involvement in quantum computing, could you shed light on how AWS is integrating quantum technologies into its services, and what potential impact do you foresee quantum computing having on business utilizing AWS? And how is AWS positioning itself in the quantum computing landscape?
Yeah, it's really interesting. Quantum is one of those things that always seems like it's just over the next hill. And so we as AWS have said, how can we give customers a feel for how they might interact with a quantum computer? How might they modify their workflows to take advantage of the potential increases that they could get from quantum technologies, while at the same time acknowledging that the science is not there yet. And there's lots of work to do that is purely research and development. And that's why we've kind of taken a two-pronged approach. On the one hand, we've got our Amazon Braket service, which is a service that allows customers to have virtual access to a quantum computer of their choice from various of our partners, and it's abstracted away so they can interact with it and they can get time on a quantum computer to see how their workloads might benefit from that and start programming against it. We really see the day coming in the future where, similar to how we have seen the onset of accelerated workloads coming on to processing more with GPUs in some cases than on CPUs based upon the requirements of their workflows, we see a day where you could imagine a portion of a workflow also being ported not from CPU to GPU, but from GPU to quantum. And so that's where we really think it's important for customers to be able to have that flexibility to look at how they would modify their workflows if they had those capabilities. But that's not enough. We think, as I said, that the science itself still needs to be proven out. And so that's why we've created our own quantum computing chip fab. And that's why we're developing our own quantum chip on Amazon. And so we have a whole team in a partnership with Caltech that is developing our own quantum computer with our own based technology so that we can keep driving that innovation forward, because we really believe that there will be a time in the future where these workloads will be able to accomplish accelerations that have heretofore not been seen by either CPUs or GPUs. But the science just isn't there yet. So basically, we're asking people to, hey, start preparing for it, start looking at the technology, play around with the bracket service, see how you could benefit from it. And in the meantime, we're going to keep innovating along with our partners on the quantum side of pushing the actual design of a quantum computer forward.
Thank you, Ian. That sounds really inspiring. So with your expertise, we're really curious about the future. Can you give us a glimpse into the upcoming innovations and technologies that AWS is currently exploring? And how do you envision AWS continuing to lead the way in driving technological advancements, especially in areas like supercomputing, HPC, AI, and quantum computing?
Well, as I alluded to a little bit before, it's really exciting to see now that we've built out these past 6+ years of infrastructure improvements to now we are at the scale and we've developed the skills, whether it be things like air cooling to water cooling, whether it be things like CPUs and GPUs, and not just from our partner vendors. As I said, we are very committed to our partners from NVIDIA, Intel, and AMD, but we've developed our own silicon, and that's where we're really excited about continuing to innovate, is in our Graviton ARM roadmap, as well as our own training and inference chips, Trainium and Inferentia, which are our custom silicon that we've developed to be more price performant for our customers to provide that innovation in that GPU space, because we really believe that customers are going to continue to push this boundary of infrastructure performance, especially with the demand we've seen with artificial intelligence, machine learning workloads. And we don't see that slowing down at all. I mean, there may be a change as people move from more a large language model to a smaller language model. We're not really sure where that's going to go yet in the industry. We may see a point where some users will move from training algorithms to where it's more of inference. They've already done the training of their foundation model, and so they're at a point now where the majority of their compute cycles may move to more of an inferencing, getting answers out of all that data that they put into those models. That's really where we're seeing is this next year. I think it's going to be exciting to see if things just continue to rocket up on the training large language models, or if we see kind of a little tempering of that and people starting to pivot more to smaller language models and inferencing.
Thank you, Ian. To wrap up, what message or insights would you like to share with our audience today? And why should they be excited to be part of the SCA 2024 with AWS as our platinum sponsor?
Well, this is an exciting time in supercomputing in general. I think, as we've talked about, it gets a little hidden. I mean, I'd say the general public now at least is starting to know the term artificial intelligence, but what they don't realize is artificial intelligence is basically a use case of supercomputing. And we've been doing the infrastructure to underlie the training and inferencing of machine learning algorithms for decades. And this is all built upon the learnings of the supercomputing industry. And so that's why everyone should be excited about coming to SC Asia, so they can learn about the latest and greatest improvements in the technology and the roadmaps and where we're headed as we're part of this really exciting time of artificial intelligence exploding onto the public consciousness.
Thank you, Ian, for sharing your valuable insights into the innovative work happening at AWS. And we really appreciate your time and look forward to see to the exciting developments AWS continues to bring to the landscape. To our audience, make sure to attend AWS workshop and plenary talk given by Simon Elisha, the Chief Technologist at AWS. We look forward to seeing you at the conference.